Hello everyone. Today we are going to look at a question of the about the S law, that was done by students of Miranda Boys. Question 4. Question 4. Question 4 which reads Question 4 which reads, what is meant by the term enthalpy of formation? Enthalpy of formation is the energy change that occurs when 1 mole of a compound is formed from its constituent elements. Formed from its constituent elements. Roman 2 reads, the enthalpy of carbon, methane and hydrogen are indicated as below. As you can see, carbon burns in oxygen and the enthalpy change is the enthalpy of combustion is -393 kilojoules per mole. Hydrogen burns in oxygen to produce water. Enthalpy change is -286 kilojoules per mole. And the enthalpy of combustion of methane is -890 kilojoules per mole. Now, the question is asking, draw an energy level draw an energy cycle diagram that links the enthalpy of formation of methane to the enthalpies of combustion of carbon and hydrogen and methane. So, methane is formed from carbon. Methane is formed from carbon reacting with hydrogen to form methane gas, methane gas like that. So you balance this equation, balance by putting a 2 there. The equation is balanced. So here we are told carbon burns in oxygen. Carbon burns in oxygen to produce carbon dioxide, and water, that is hydrogen, burns in oxygen to produce water. The same case when we burn methane. In presence of oxygen, we will produce carbon dioxide and water. So that is the energy cycle diagram that is linking methane, carbon and hydrogen. So you should make sure that these equations are balanced, like you balance this equation for burning methane. You can see we have 1 carbon, 4 hydrogen, 2 hydrogen. We balance by putting a 2 there. And oxygen, they are 4. You balance by putting a 2 there. So that those equations should be balanced like that. That shows the enthalpy, that is the energy cycle diagram. Determine the enthalpy of formation of methane. Determine the enthalpy of formation of methane. So here you say enthalpy not 1, enthalpy not 2 is root, enthalpy not 3. So you use this formula here and say this root is equals to this root plus this root according to Hess's law. This root 1 is equals to root 2 plus root 3. So you say root 1 is equals to root 2 plus root 3. So we are asked root 2. We are asked root 2. So we begin by calculating root 1. Here we say carbon burns in oxygen to produce this one, to produce carbon dioxide, and the enthalpy of combustion is negative 393 plus that one of oxygen, which is that one of hydrogen, which is, as you can see, we have 2 moles of hydrogen and here we had 1, so multiply by 2 times the enthalpy times negative 286 is equals to the enthalpy not 2 plus this root here. When we burn then the energy produced is negative 890 kilojoules. 890 kilojoules. So we need root 2. This is negative 393 plus minus negative 572. This will give us negative 965 is equals to root 2 plus negative 890. So we need the value of H2. Need the value of H2, root 2. So we say negative 965 plus 890 is equals to root 2. So our root 2 is equals to negative 75 kilojoules. Remember, this case should be a small letter, kilojoules per mole. Negative 75 kilojoules per mole. Thank you for watching. Please share this video and subscribe.